Hi everyone, so this is section 5.4 and it is on a brand new concept called function notation. But actually this concept is just a fancy way of saying something that we've been doing for a really long time. So it's really nothing new, we're just going to call it something new. And I want you to remember that as we move through this lesson. We've been doing this skill for years, okay? We're just calling it something a little bit more fancy, and I'll tell you why we're doing so. So this term, function notation, it's just a different method for writing functions where y is the same thing as f of x. And that's how we read it. F of x is read as f of x. And this is really important. Okay? So guys, now instead of seeing, like we've seen this for years, right? Y equals 2x plus 5. All we're doing is we're not going to use that y anymore. We're going to say f of x equals 2x plus 5. Really important to note here, it does not mean multiplication. A lot of times when we see like f of x or f parentheses x, we think that means multiplication, but that's not what it means. I'm so sorry guys, I just lost my spot. F times x, does not mean times. This simply is just the same thing as y. Pretend this has to be together at all times. They're like twins. They're attached. Okay, guys, why we do this is because we could have f of x. I could replace this f with really any letter. It could be g of x, h of x, p of x. It could be literally anything. It's a function of x's, okay? And why we are maturing to something called function notation, right? We're in high school math now. If I had a graph, and let's say I had this line on it, and this line on it, okay? Guys, if they were all y equals, and I told you, oh, look at the line, y equals, you wouldn't know which to look at, right? So what we want to note is now I could say this one's f of x equals x plus 5. This one's g of x equals negative 1/2 x plus 2 or plus 5. And this one's h of x equals negative 2. So now when I say, look at this graph, here on this graph, look at function g of x. You know exactly which line to look at. So when we mature into higher level maths, we're starting to look at a lot of graphs at one time. A lot of graphs on one coordinate plane. So that's why we can use function notation to name different lines, different graphs. So let's talk about, see, this is what we're used to. Y equals 2x plus 5. Guys, all we're learning in this lesson is now we could say f of x equals 2x plus 5. And vice versa. If you see f of x, just know it's the same thing as y equals 1/2 x plus 3. Okay? In order to distinguish between functions, distinguish between graphs on like lines on a graph like I just showed you, we can use multiple letters for f. It could be G, H, J, or other common letters. So what we're really talking about in this lesson is how to evaluate functions, And there's two steps that we need to do to evaluate functions. And again, we've really been doing this before, so it's nothing new. The first step, we need to substitute the number for the variable in the expression, and then we just need to simplify the expression, and we can write our solution as an ordered pair. Remember, an ordered pair is usually x comma y. So guys, it still is, right? X comma f of x is the same thing as x comma y, because we just said y is the same thing as f of x. So this might look fancy, but it's really just still x comma y. So let's practice. It says use this function. So they give me a function, f of x equals 2x minus 5. And they say, okay, find f of negative 3. So what we're going to do is I'm going to say, okay, f of negative 3. And I want you to think about this. What's the difference when you look at this and when you look at this? What's the difference? The only difference is instead of an x, there's now a negative 3. So what that means is everywhere I see an x, I need to put this number. I need to substitute the number for the variable. So I'm now going to have 2 times negative 3 minus 5. And then we just simplify that. So I have f of negative 3 equals 2 times negative 3 is negative 6 minus 5. F of negative 3 equals negative 11. So what that means is when, and let's write this out for the first time, when x is negative 3, y, or f of x, equals negative 11. We can write that as a point, negative 3, comma, negative 11. It's our x value and our y value. Let's check out another one. I have for h of x equals 2x plus 4, find the value of x when the function h of x equals 16. So this is the other way around. This time it wants me to find the value of x when h of x equals 16. So they're telling me the function h of x equals 16. I find h of x and I'm going to substitute 16 in for h of x. And then notice what's left is the x value. That's what I'm trying to find. So now I'm going to subtract, just solve this. Solve for x. Subtract 4 on both sides. Divide by 2. So now I know when x equals 6, y, or h of x, equals 16. And I can write that as 6, comma, 16. Okay? We can also do this on a graph, guys. So remember, if we see f of 2, remember what this usually is. This usually says f of x. So instead of the x, there's a 2. When I look at a graph, I go to where this is an x, right? I go to x is 2 on the number on the x-axis. Here's the x-axis, here's the y-axis. I go to x is 2. I find that point on the graph, right, on the function I'm looking at, and you could look right here, and I'm looking at what's the y value, because this whole thing equals the y value. The y value is 5. Let's check out another one. So this is saying when x is 5, what's the y value? It's 1. Okay? This next problem is the other way around. It says find out what x is when the function, remember, f of x is the same thing as y. So when y is 2, what's the x value? 3. And one more here. Find x when your y value is 4. Find y value is 4. Oh, here it is, here it is, and here it is. I can actually have 3 answers. So when y is 4, my x is 0. Let's call that 1.5 and 2.2. Okay? That's how we evaluate using a graph. These are just some practice problems. I'm going to go through them. So notice we've got 3 functions, f of x, g of x, and h of x. And we're going to use them like when they tell me to use them. So for the first one, this says f of 4. So guys, if it's an f, I'm not going to use the g of x, and I'm not going to use the h of x. That's telling me, that's the cool thing about function notation. It's just simply, real easily telling me which of these functions to use. So I'm going to go do f of x, and I can write that down. F of x equals 6x plus 9, but now I want to evaluate when x is 4. So I substitute 4 in for x. Okay, and then I'm going to have 24 plus 9, which gives me 33 is my answer. Okay, let's check out this one. G of negative 2. So I go to my g function, and I'm just going to copy that down. G of x equals negative 1/2 x plus 3. And now I want to do, okay, g of negative 2. So I'm going to have negative 1/2, substitute in negative 2 for x, plus 3. And then I'm going to do negative 1/2 times negative 2. The 2's cancel, and I have a negative times a negative. That gives me a positive 1 plus 3 gives me 4. Okay, h of negative 9, I know exactly which function to use. So I'm going to copy h of x equals the absolute value of x plus 1. So then I have h of negative 9. I know what to do with that negative 9. I substitute it in for x. And then I simplify. Negative 9 plus 1 is negative 8. Guys, what's the absolute value of negative 8? It's positive 8. Okay? Now these two are the other way around. So I have find x if g of x equals 21. So I go to my g of x function, which says g of x equals negative 1/2 x plus 3. But this is telling me the y value. The function is 21. So I substitute that in for that whole thing, g of x equals negative 1/2 x plus 3. And we're going to solve this. I'll subtract 3 on both sides. And I'm going to get 18 equals negative 1/2 x. We know how to get rid of this fraction. Remember, that's when we multiply both sides by the denominator. And I'm actually going to do negative 2. And I'm going to get a negative 36 equals x. And then we've got one last one here to do. Find x when h of x equals 10. I go to my h of x one. And I have h of x equals the absolute value of x plus 1. So I have the absolute value of x plus 1 equals 10. Remember how to solve absolute value equations? We have to set it equal to positive 10 and negative 10, and I get 2 answers. 9 and negative 11. So guys, what's important here is sometimes when you get down to this line, you want to divide by 4 to get the variable by itself. Just remember that whole thing is a package deal. This is really the same thing as saying y equals 33. And then you would know you're done, okay? And we've just got 2 problems to talk about here. It says the games you play at the amusement park average $5 per game, $5 per game, and your ticket was $50. Which of the following functions represents the cost C per day based on the number of games you play? So right away, I know I'm paying $5 per game. If I play 1 game, $5. 2 games, that would be 10. 3 games, that would be 15. That's how I know I'm multiplying. And then I'm already up front paying $50. So that's how much I pay to start, and then $5 additional for each game. So that's why my equation is going to be B, 5G plus 50. And then this last problem here, coronavirus is attacking the world. The function C of t equals 9t minus 4 determines how many people have the virus, where t equals time in days, C of t equals number of affected people in thousands. Find C of 3. Again, we know what to do. Take that 3 and substitute it in for t. Simplify. And that 23 means after 3 days, because that's what I plugged in, after 3 days, 23,000 people have been affected. And then the last question says find t when C of t equals 32. I take the function and set it equal to 32. And then I solve this. And I get 4 equals t. That means it takes 4 days for 32,000 people to be affected. Okay, so these can be really easily applied to real world problems. Alright guys, that's section 5.4. Great job!